You ever wonder why so many AI projects, the ones that look absolutely amazing in the lab, just completely fail in the real world? Well, it's usually not the algorithm. It's the powerful, almost invisible infrastructure that's supposed to be supporting it. Today, we are diving deep into a really critical piece of that system. So let's just start with the question that kind of haunts every data scientist and engineer. You spend months, right, building this brilliant model that just aces every single test on historical data. But then, the moment you deploy it to make live decisions, its performance just falls off a cliff. Why does that happen?
And the answer, more often than not, isn't the model itself. The real culprit is the data infrastructure. Think of it like the complex plumbing that's responsible for feeding your model the precise, real-time information it needs to make smart decisions second by second.
So, what is the core challenge here? To really get why the solution is so important, we first have to get a super clear picture of the problem that every single production AI system has to face. Okay, so here's the deal. Machine learning basically lives in two completely different worlds. First, you've got the offline training world. This is like a library, where your model just studies these massive historical data sets for weeks, learning all the patterns. But then it has to go perform in the online serving world. And this is the real world, right, where it needs to make instant predictions using live streaming data. These two worlds, they operate at totally different speeds and scales. And that's where all the chaos begins. This conflict creates this notorious problem called training-serving skew. And in simple terms, it's just when the data your model trained on doesn't perfectly match the data it sees live. And even the tiniest difference, a calculation done a slightly different way, a data source that's just a millisecond out of sync, can cause your model's hard-won accuracy to just plummet right when you need it the most. So how in the world do you bridge this gap? How do you make sure the data your model sees out in the real world is identical to the data it learned from? Well, the solution is a powerful and honestly an increasingly essential tool called a feature store. So what is it? A feature store is basically a central library for all the prepared data, the features that your models need to think. Its whole purpose, its reason for being, is to serve these features with absolute consistency, whether you're in that slow offline training world or the super fast-paced online world. It really becomes the single source of truth for all of your model's data. And this is where it gets really, really cool. A feature store directly attacks all the problems we've been talking about. It guarantees consistency, so you can just say goodbye to training-serving skew. It's a central place for everything, which means data science teams finally stop wasting time reinventing the same features over and over. It becomes this collaboration hub, it enables the lightning-fast data access you need for real-time AI, and it gives you a perfect audit trail for governance. It's a huge win.
Okay, so how does this thing actually work? Let's just peel back one layer and look at the core concept without getting totally lost in the deep engineering weeds. It's actually surprisingly elegant. It all starts with your raw data from all sorts of different sources. That data flows through a transformation process, which we often call ETL. That just stands for extract, transform, and load. This is the critical step where all that raw, messy data gets cleaned up, calculated, and shaped into valuable predictive features. Then, and only then, are those polished features loaded into the feature store, totally ready for action. Now, here's the secret sauce. A feature store is actually two specialized databases working together as one. You've got the offline store, which is this massive data warehouse holding terabytes of historical features, perfect for training those deep, complex models. Then you have the online store. It's a sleek, hyper-fast database that holds only the most recent feature values optimized for near-instant lookups. This brilliant dual architecture is what lets it serve both of those worlds perfectly. All right, let's see how this works with a classic example where speed and accuracy are literally everything: fraud detection. And while this is a great case, just keep in mind this exact same pattern applies to recommendation engines, dynamic pricing, or really any system that needs instant intelligence. Okay, so a customer swipes their credit card. The clock starts ticking right now, instantly. The fraud detection model immediately needs answers. What's this customer's average purchase size? How many transactions have they made in the last 10 minutes? Where in the world was their last purchase? The system pings the feature store's online component to get these fresh, up-to-the-second features. And it has to be fast. Incredibly fast. We are talking less than 100 milliseconds. That's a fraction of a blink, to retrieve all of that data and serve it to the model.
There is zero time for a slow query. That's precisely why you need that optimized online store. So, armed with these consistent, low-latency features, the model makes its call, approved or blocked. And because the features are identical to the ones it trained on, that prediction is actually reliable. The whole process is over before the customer even puts their card back in their wallet. So, you can start to see that a feature store isn't just another database. It's really more like the central nervous system connecting your entire machine learning ecosystem. Let's see how it all just comes together. Your big model training jobs, they pull mountains of data from the offline store. Your live applications are making these surgical, high-speed calls to the online store. Your monitoring tools are watching the features for any drift, warning you if your data landscape is changing. And governance tools use its catalog to track data lineage. It truly is right at the heart of modern MLOps. Okay, let's bring it all home. Why is understanding this piece of the puzzle so critical for anyone who's building or, even just following the world of modern AI? Well, the impact is a total game changer. You get a massive lift in consistency, which means more reliable and trustworthy models. You unlock the speed you need for truly real-time interactive applications, and you gain this enormous reusability, which dramatically accelerates how fast your teams can build and deploy new AI products. If you think of your whole AI system as a body, the feature store is its heart. It's the central engine, just tirelessly pumping clean, consistent, life-giving data to every single other component, making sure the entire system functions as a healthy, coordinated whole. So what's the bottom line here? What are the key things to remember? First, great AI is always built on a rock-solid data foundation. Second, feature stores are the definitive solution to that training-serving skew problem that just kills so many projects. And finally, they are the key that unlocks the consistency, speed, and governance you have to build AI at enterprise scale. So I'll leave you with this one question. As you look at the AI systems being built all around us, what's serving as the heart? Is it strong? Is it consistent? And is it reliable? Because as we've just seen, the health of the entire system really depends on it.